You know that the multiplication of both whole numbers and fractions can be represented using an array that looks like this. This example shows 4/5 multiplied by 2/3. The product of multiplying the fractions is 8/15. You also know that division is just another way of writing multiplication when one of the factors is unknown. That's easy to see using this array. Let's assume that you know the total size of the array, which is 8/15. And you know one of the factors in the multiplication, 4/5. But you don't know the other factor, which we'll now call x. X is the number you need to multiply by 4/5 to get 8/15. We can represent this situation with two different number sentences. The first number sentence is written as multiplication. We know that 4/5 is multiplied by some number on this side called x, and the result is 8/15. We can also describe exactly the same situation with a division number sentence like this. We know that we have 8/15, which is divided by 4/5. But we don't know the length of this side of the array, which is the value for x. So these equations tell us exactly the same thing, because they represent the same situation shown by the array. The x in both equations represents the same number. It's the missing value for the length of one side of the array. While this array is helpful in seeing what a division problem represents, it's not very helpful in finding out the number we need on this side, because we don't know how many parts to divide each whole unit into. So how do we find this number? The best way is to use what we know about algebraic reasoning, using these two equations to describe the array. We'll start by finding the value of x in the multiplication equation. This will help us later in understanding how to solve the division equation. You know that you can multiply both sides of an equation by the same number, and it doesn't change the equation. We can use this to our advantage if we choose the right number to multiply by. We want a number that will give us 1x instead of 4/5 x on the left side of the equation. You know that multiplying any number by its reciprocal gives you 1. Let's multiply 4/5 by its reciprocal like this. 5/4 times 4/5 is 1, so the left side of the equation now becomes 1 times x, which we write as just x. You also know that if you multiply one side of an equation by a number, you have to multiply the other side by the same number. So we multiply the right side of the equation by 5/4. When we multiply, we get 40/60. We can divide both terms by 20 to see that x equals 2/3. When we compare this to the multiplication problem we started with, we see that 2/3 is the correct answer, because 2/3 times 4/5 is indeed 8/15. But how does this help us understand how to divide fractions? It's actually very simple. Let's look at these two statements from the equations. Remember that x represents the same number in both equations. It's the length of this line in the array. The equation on the right says you can find x by dividing 8/15 by 4/5. The equation on the left says you can find x by multiplying 8/15 by the reciprocal of 4/5. Using what you already know about algebra, you can prove that the same approach always works, but we won't go through that proof here. It means that dividing any number by a fraction and multiplying that number by its reciprocal gives you the same result. We'll just look at a couple of examples to verify that this works. We'll start with this multiplication statement. 3/4 times 5/8 equals 15/32. Now, let's find the answer to the related division problem. 15/32 divided by 3/4. We multiply 15/32 by the reciprocal of 3/4. We get 60/96. Then rewrite the fraction as 5/8 by dividing both terms by 12. We can check our multiplication statement and see that 5/8 is the correct answer. One last example. To find the results of the division, multiply the reciprocal of the divisor times the other factor. The result is 12/5. So 6/5 divided by 1/2 is 12/5. In the remainder of this lesson, you'll do some problems like this on your own.